In this video, we're going to try to develop an understanding of where the formula for standard deviation comes from. It's a complicated formula, so it helps to break it down a little bit and see why it is the way it is. Okay? So let's use a very simple data set. Very, very simple. So our data set will include only two values, 2 and 8. Very simple data set, just so we can see where it comes from. Okay? Now we want to find the standard deviation of this data set. So how do we go about doing that? Now remember, the standard deviation is the standard amount data deviates from the mean. Okay? Or the average distance from the mean. So in order to find a formula for the standard deviation, we're first going to need to find the mean for this set of data. If we want to know how the average amount we are from the mean, it's helpful to find the mean. So step one is going to be to find the mean. Okay? And we're going to assume we're talking about a population here. So I'm going to use mu for our mean. And if you remember the formula for mean, we add up all the x's, we divide by how many there are in the population. Okay? So we only have two values. So when we add up all our values, all our data values, that means we get 2 plus 8. That's what that numerator means. And on the bottom, we divide by how many there are. And there's 2 values in our data. Okay? So 2 values in our data. So 2 plus 8 is 10, divided by 2. That means our mean, the mean of this very small population, is 5. Okay? Now, we want to find the standard amount the data deviates from the mean. So how are we going to do that? Well, the first thing we're going to do is we're going to calculate how far each data value deviates from the mean. Okay? So for each data value, we're going to calculate x minus mu. Okay? So, and let me make a little table here. I think it'll make things a little easier to see what's going on. So we're going to do this for our two values. We have 2 and we have 8. Okay? So what's that going to look like for this guy? That means we have 2 minus our mean of 5. And down here for the 8, that's 8 minus our mean of 5. So we do this for each data value we have. We want to know how far is each data value from the mean? How much does it deviate from the mean? Okay? So 2 minus 5 is negative 3. And 8 minus 5 is positive 3. Okay, so what does that tell us? 2 minus 5 is negative 3. So the number itself is the distance. 2 is 3 units away from 5. The negative tells us a direction. The negative says this is 3 units below the mean. It's smaller than the mean. Similarly, 8 minus 5, we get 3. 3 is telling us that's the distance from the mean. So 8 is 3 units away from 5. Okay? That's how far it is. And then there's an invisible plus in front. We usually don't write the plus when it's a positive number. But that plus is also telling us a direction. It's telling us that we're 3 units above the mean. 8 is 3 units bigger than the mean. Okay? Now, here's the thing. We're getting more information than we really want. We're getting the distance, and that's what we care about. That's how far we deviate from the mean. But we're also getting direction. That minus, this plus. We don't want direction. Okay? We just want that distance. So how do I get rid of the direction argument? How do I get rid of the sign? Well, one approach, and this isn't wrong, but it's not the way we're going to do it, is to just use an absolute value, right? Get the absolute value of negative 3. That gives us 3. Absolute value of positive 3 gives us 3. Remember, absolute values just turn everything positive, and that gets rid of the direction. So we're just focusing on positive numbers, which means we're just focusing on direction. And it's not a wrong answer, okay? But that's not the way we're going to do it. And the reason is absolute values can be a little bit tricky in advanced mathematics. If you've taken calculus, you might know that absolute values, they have some problems because they're not smooth, right? So we're going to use a different approach, okay? I still want to get rid of that sign because that's the direction. But instead of taking an absolute value, I'm going to square it. Okay, so that means for here, that's going to be -3 squared, which is +9, and +3 squared, which is also +9. So remember, squaring something always turns it positive, which means we get rid of that sign data. We get rid of that direction data. Okay, it's not, we no longer are told the direction, we just have that distance. Now, by doing this, we do get rid of the distance, but we introduce a different problem, right? This is no longer the distance. This is the square of the distance, right? This is 3 squared, not just 3. We'll have to adjust that later, okay? For now, that's what we're going to work with. Okay, so I have these values. Now what am I going to do with them? I want the standard deviation, or the average distance. So I'm going to average them, okay? So I'm going to take that x minus mu squared for all my x's, for all my data, in this case, 2 whole data points, okay? I'm going to add them up and divide by how many there are. That's how we calculate an average, right? We add everything up and we divide by how many there are. It's just what we're adding up looks a little more complicated, but it's still just, we're just adding these bits up and dividing by how many there are. So the x minus mu squared, we calculated them. The first one, the one that corresponded when x is 2, is 9. And when x is 8, it's also 9. So not very interesting. They're the same. They won't always be the same, but very boring in this case. So we add up our little squared deviations, 9 plus 9, and we divide by how many there are. There's 2 total, right? We have 2 data points. So 9 plus 9 over 2, that's 18 divided by 2, which is 9. Okay? Now remember, there was something we had to fix, right? We squared things, and that got rid of the sign, the direction information, no problem. But it also squared our distances. So now we need to unsquare our distances. We can unsquare things by taking a square root. So I don't want just this. This is the average. Then I'm going to take a square root to correct for the square. Okay, so square root of all of this. And that's going to give us 3. Okay, that is the standard deviation for this data. And when we look at it, that shouldn't be too surprising, right? When we calculated over here, we saw that this was 3 units from the mean. This was also 3 units from the mean. So the average or standard amount we deviate from the mean is 3 units. Not terribly surprising. We went through a lot of work to get that over here. For a more complicated set of data, it may not be so obvious and we'd have to go through all these steps. Okay? But hopefully that sort of makes sense, the process. And it shows us our formula. So let me write it down here so we have it nice and neat in one place. Our formula for calculating our population standard deviation, and we notate this with the Greek letter sigma. Okay? Greek letter sigma. It's the lowercase Greek letter sigma. So the population standard deviation is, and I like to kind of build it out so I remember why the formula is the way it is. We look at each data point and how far it is from the mean. We square it to get rid of the direction information. We average it. So we add it all up and divide by how many there are. And then we take the square root to correct for the square. Okay, that's the formula for the population standard deviation. Now notice we have not talked about the formula for the sample standard deviation. It's just a hair different. We'll talk about that in a future video. For now, we're going to focus on the population standard deviation, and in the next video, we will see a more complicated example of how to find the standard deviation of a population using the R calculator that we're using for the class.